So, good morning, everyone. I'm Nicolai. I'm working as SRE at Bolt, and I will not be describing what Bolt is because I guess that almost everyone was using it at least once. And I'm happy to open the second day of the conference with my talk about infrastructure as code platforms. It's not much about monorepos. It's mostly like a trendy topic, but I will include that a couple of slides about that as well. So in general, in my last 5 years or so, I participated in different projects related to infrastructure as code, built some platforms with that, with different infrastructure as code tools. So basically, this talk is based on my experience. And so let's start. Basically, some people can think that what is so hard with infrastructure as code? Right, so basically you just install tool from locally on your laptop, like Ansible, Terraform, or Pulumi if you like to be on hype, and then you basically like copy some example code from the internet, run it, apply, something's happened, and in the end you get some happy end. And unfortunately, it's not that simple, and there are some details and nuances that define the end result. So it depends how infrastructure code is written in general, where it is stored. Are there any quality gates on the way of this code from the development to the end result, like to the applied state? And is there any like work release life cycle of the infrastructure as code at all, or we just like fire and forget? So how infrastructure as code could be written? It could be, we could use some like very simple editors like Notepad, TextEdit, or like Nano on Linux if you are a fan of that. Or you can use proper IDE like VS Code IDEA with some proper plugins, and they will help you to develop the code. They will highlight syntax, they will make auto-completion, they will validate your code in real time, show errors in real time. They will help you to, for example, show the Git blame in real time on the line, so you can just navigate through the code and understand what line was added in what pull request, and you can even see Jira links attached to that, and so on. So next one is the how code is written in terms of not the structure, but from the beginning to the end. So basically, every engineer could use his imagination and create like very weird stuff. And unfortunately, I saw that a couple of times. So basically, people do not checking the best practices and just reinventing the wheel and doing some very weird stuff. And it's very hard later to get rid of that. So basically, all the tools has best practices, which I guess everyone should follow. And then like last one is code itself could be structured like in some unified way that we agree that this should be put here and that should be put there. But we can have random structure when everyone just like put whatever they want or whatever they need. Like, and for example, yeah, they could like keep everything in one state in Terraform, or they can just create like folder 1, folder 2, and you can never like understand what is folder 2 and folder 1 and why it's there. Next one, yeah, it depends like where code is stored. So you probably can be surprised, but I saw a couple of years ago Windows administrators. Luckily, they were storing the code they were developing for some local automation on the local laptops, and they were sharing it via email or shared folder, I don't remember exactly. And this is still happening. And also you can store your code in some 90s stuff like SVN, some local Git without UI and whatever. So basically it's a black hole. You just dump something there, and you should just know where it is, first of all, to find it. And then you don't have like any, you cannot have any CI, like pull requests there, any UI and whatever. Or you can use modern code collaboration services like GitHub, GitLab, and maybe Bitbucket. I haven't used it much, but I guess it kinda similar. And the next one, the last one, is the life cycle of the infrastructure as code. So we can just push code to the master or main branch and forget about it. Or we can forget to push to the main branch, and that's it. You never know like what is applied where and why it was here, and just like some like miracle. Or we can use pull request workflow, and we can use code review, quality gates, which ensure that code is passing some stuff, and we are okay with that. And we can have automation to apply these changes. And the next slides, I will describe this more in details. So what can we have achieved like in the worst case scenario I can imagine? So we can have in the end unusable mess with just code which no one wants to touch, and no one knows what is there and why it's there, and is it applied or not, or just like someone pushed that. We have no collaboration because basically like if this engineer like who is pushing that, they're not sharing this like in a verbal communication or somehow either with other team members, no one will know like what is really like why it was done. We will have no code reuse because it's probably simpler to just like fire and create another dump instead of like reuse previous configuration. And the infrastructure as code is spread everywhere. Like as I mentioned before, like we can have something on the local laptop, we can have something in some one repo and something in another repo, something in GitHub, something in GitLab, because why not? And we have configuration drift, because basically everything we have is not like confirmed that it's applied. It's just like, if it is, then it's good, but if it's not, you will never know about that. You will find this out only when you will try to change something there. And in this case, I would say that infrastructure as code is not useful and not differs much from the just some manual changes via UI or whatever. Because what's the difference? Because it's house in both sides. So after this horror scenario, what can we do, I think? And it's actually really, I built a couple of them and these platforms, and it's working. So I named this infrastructure as code platform, and it consists of different components. Like first of all, it's onboarding documentation, which includes information on how to start working with this platform, how it's built, what is the life cycle, and more of this later. It consists, next part is code collaboration. As I mentioned before, this GitHub, GitLab, code review, and workflows like that. Quality gates, and automated release of the code in the end when pull request is merged. So what we have in onboarding docs from my perspective? We have quick start documentation, which includes something like what local environment of engineer looks like, which tools should be installed, which ID we are using. So it could have some automation like brew file or whatever to set up this automatically, like to not do it manually, because manual job is not like repeatable much. It should have development workflow documentation, which describes what is the life cycle of code, like where do we start, how do we proceed with like creating changes, reviewing them, and then like how in the end code goes to the life. And it should also have tool-specific docs. For example, generic documentation about how platform works, but probably we should have some documentation about like how do we use Terraform or Ansible or whatever in general, like what do we think is good and what do we think we shouldn't use, and all stuff like that. And if you have any issues, like some workarounds and stuff like that. And this documentation is worth to add to the onboarding documentation of new engineer. For example, when new engineer starts, it usually receives some like amount of links to the Confluence, for example, and this documentation should be there. And this helps like to unify. And this documentation, it sets like happy path of the infrastructure as code development. And you can always like be different and decide to go another way. But in this case, you just lost all the support from the platform itself. So basically like you are on your own with your problems. But when you are going through the platform documentation, you can always like ask help from the other team members, and they will help you with that. So what includes code collaboration? So basically, protected main or master branch ensures that nothing can go there, not through the pull requests, and it ensures that quality gates described on the next slide are actually enforced, because otherwise, if you don't have protected main branch, it's just like goodwill of every engineer. Like if they will use pull requests or not, they will just push to the master or main branch, and in this case, it's like someone will be just shitting in your pocket. And pull requests also help you to code review, and code review helps to share knowledge. And at least like if you have one approval, you will get at least one more team member who will check your code. Maybe even it goes to production, so you can catch issues in your code earlier. And it is always cheaper to fix issues before than later. And ownership is the part of this code collaboration, because when this platform became big enough, you don't want to be the part of every change in this code. So for example, you have parts of the code which are owned by the separate team, and you delegate it to them, and with ownership, you can delegate it there, and you will be not getting any notifications about changes there, and you will don't have to review that stuff. And with big enough platforms, it's very helpful, because otherwise you will be just burned out. You will get just like dozens of pull requests every day just for the review. And third component is quality gates. Quality gates helps you to ensure that all the code that passing through the pull request and code review is good enough to merge it. Like you can have no quality gates, but in this case you will have to spend like more time on reviewing that stuff. And different people could have different opinions. But when you build these quality gates, they will just, you don't have to bother with, if the pull request is green, then it means that it's more or less okay, and you can just spend time on reviewing actual things, but not like wasting time on tabs versus spaces, how much spaces, and like new lines, code style, or whatever. So basically, quality gates consist like of different things, like basic linters, format check. It could be validation for structure, like if code is valid, and it could be check for the best practices following. And also you can have custom checks, like for example for the structure, you can also have a check that will ensure that structure is as expected. So like no one will put like some stuff at the place that shouldn't be there. And also security stuff is quite like on rise right now. There is like a lot of tools for different infrastructure as code, which helps you to ensure that, for example, in Terraform, you don't have wide open security groups and some like other stuff, like unencrypted S3 buckets, open S3 buckets. It also has like has a lot of not very useful stuff, but you can always tune that. Quality gates could be at different stages of your code path. And I suggest to start first with the pre-commit hooks, because pre-commit hooks will not allow you to push even changes to the branch if they will not pass the quality gates. And then the next checks are on the stage of CI, and you have can have like different workflows there. And one more thing is that quality gates should be fast. Especially it's important when a repo gets big enough. You shouldn't check like for all the like thousands of files in repo on every pull request. You should check only for the stuff that changed, and maybe for the stuff that relates on the changed stuff. It's not very easy, but it's kind of achievable from my experience. And the last part of this platform is automated release. It means that there is some magic in the end that allows you to delegate applying of the stuff in the end, like before the merge in some cases, or when it's approved and reviewed, or on the merge. And this stuff is helping you to minimize monkey job, basically. So even if you delegate some stuff with ownership to other teams, if you don't have automated release in the end, you will still be teams will be pinging you if they don't have access to somewhere, like we have this pull request, it's approved, but let's then apply it now. And with dozens of pull requests every day, you will be doing like very useless job. Even if you set up some like workflow with Jira tickets to apply every pull request, it's still like a useless job. And it helps to split and delegate ownership. So like if you have, for example, some accounts in AWS or other clouds which are managed completely by like data engineering, for example, teams, you can delegate completely non-critical stuff there. So they, for example, can create some S3 buckets there, some EC2 instances or whatever, but they cannot change, for example, some critical stuff like security, like IAM policies or like some security stuff. So basically you are covering in that account critical paths with your ownership or security guys' ownership, and they should approve that. But they can still like do all the workflow without your intervention, thanks to this automated release and code ownership. And some examples of this automated release, it could be Atlantis for the Terraform. So it's basically automation which prints your plan of your Terraform plan in the pull requests, and when pull request is approved, any engineer who has like write access can write Atlantis apply, and it will be applied. Or it could be for Kubernetes example, it could be GitOps. So you can use Flux or Argo, and Flux or Argo will apply automatically on merge. So why I have Monorepo in my title of my talk? Because basically Monorepo helps you to keep all this stuff I described earlier in one place. It's achievable to do the same as I described earlier with different repos, but in this case, you have just like multiplied ownership. You have like, for example, if you are changing some quality gates in Monorepo, you are changing them in one place, but with different repos, you have to go through these dozens of repos and do these changes. You can automate that, sure, but why you want to do that? It's like too much from my perspective. So it's easier to add new things and make changes to these things. Because, for example, if you have some like Terraform state and you have it in one repo, but then like you want to create some other similar stuff, in Monorepo you just can say that you can copy this example, like change some values and create pull request. After review it will be applied, and that's it. If you don't want to use Monorepo for that, you have to come up like with the name of the new repo. You have to create this repo. You have to copy some CI automation there, and then like a lot of manual work just to create the same thing, and then forget about it like till the next half a year or so. Refactoring is faster, and refactoring is owned by the person who is doing refactoring. So, for example, with Terraform, if you have some module and this module is used in dozens like of states, if it's used by the Git URL with tag, then someone can release a new version of module, then reuse new tag in his state, and forget about everyone else. But with Monorepo, and when it's just used directly in all the states, this person has to go through all the states and ensure that his changes are not breaking, and maybe like fix other states. It's not always the good idea, but it's still kind of achievable. And it's not a hard requirement, as I mentioned. So, but like if you prefer, it's just like what do you prefer, like to do more job by changing other repos or keep everything in one place. And in our cases, we have this Monorepo, and we provide support there. For example, we are updating Terraform constraints when new version is released. We are supporting CI and automation, but if someone wants to do like their way, they can use our Monorepo as example, but it's like up to them to support all that stuff. We don't, like, if they want to suffer, they suffer. And the interesting part is that a week or so ago, Slack released a nice article on how they are doing Terraform internally, and I checked it I checked it quickly, and it was interesting that they have pretty similar approach with Monorepo and stuff like that. So you should check that if you want. So I thought that the previous part of my talk was quite theoretical and too much like abstract. So I added these examples on how the structure could look like from what I saw and what we have. So basically, the first slide is about Terraform. So what people usually have, it's the states are organized by, on the left, by account and then region, and on the right, it's organized by environments. And each structure has .github. In my case, it's GitHub Actions workflows are stored there, and modules are used to store the modules, Terraform modules inside there. And basically, these modules are sourced by path, like with direct path to this module. And for GitLab case, the GitHub folder changes to .gitlab CI YAML, and it contains like all the CI, which ensures that quality gates are passed. And yeah, there could be like more files, but on the bottom, as you can see, there is readme.md, and readme.md, it's not like the full documentation, but it's just like entry point to the platform. So basically it says that this is monorepo for something like Terraform, Ansible, Kubernetes, whatever. And it describes like that documentation is located here. You can start by doing this, and the structure is organized by this approach. And the next slide shows examples for Ansible and Kubernetes. And on the left is the basically structure from best practices on Ansible, maybe slightly changed. So basically it has environments or inventories, then you have folders for inventories. It has folder for playbooks, and it has folder for roles. It has local Ansible configuration, and GitHub automation for CI, and README, as I said earlier, for entry point to the platform. And on the right is the Kubernetes. You could have some like global stuff like Helm charts. We have also customized stuff globally defined. And then you can have like different structure on, for example, in this case, it's cluster and then it's namespaces. And I just want to mention that it's not about like deploying developer services from Monorepo. It's about our internal services, how they are deployed. So it's like we are not deploying microservices from Monorepo. It's our internal stuff. Like for example, we have telemetry, quite huge stack, and it's defined here. And this is Monorepo itself, and all this platform is not the hard requirement, because basically in some cases it's worth to have code, infrastructure as code close to the code itself. Like for example, you can have Helm charts with application itself, or you can have separate Terraform repo because it has some like constraints. It's not much related to the platform. It's like only one setup, which is integrated with some automation, and it's not worth to put it to the Monorepo. Yeah, and also I suggest you to keep in README.md badges from the CI. Basically, all the CIs like GitLab CI, GitHub Actions, they provide you badges, and they will show nice green or red status, and you can always like see the overview of if CI is broken or not without going to the actions itself or receiving some notifications. And the last example is how code owners file could look like. So basically, code owners is the file which defines ownership, and it's supported by the majority, I think, of code collaboration services like GitLab, GitHub, and it's organized like this. It's kind of similar with gitignore. It just has some exceptions that are not working there. And in this example, we have Octo org/platform, which owns critical paths of the platform. So for example, we are defining that all the dot files are owned by platform. For example, Helm charts are owned by platform, and code owners are owned by platform. And we are delegating cluster 1 completely to some like foo team. And it could be like quite huge. Also, you can have some checks that ensures that code owners are covered correctly. So for example, you can have in the beginning wildcard ownership of some team, but also you can skip that, and you can just have some CI check that will ensure that new parts that are added in this pull requests are covered in the code owners. And in this case, it helps like you to get rid of the extra notifications that you don't want to receive in the pull requests. And GitHub and I think GitLab allows you to subscribe to the notifications from the new pull requests that you are assigned as the reviewer. You are getting this by default to email, but you can also set up it to the Slack. And also with this separated code ownership, you can have notifications to the Slack, to some global channel for your team, and your team will be receiving automatically this pull request. So instead of writing every time, like, please take a look to my pull request, you're just going there and you have a see like all the history of pull requests. One more thing to keep in mind, I'm not sure if you know, but code owner's file is pretty dumb, and we got this a couple of times already. So basically, if you have the owner is the last one who is matching this path. So for example, you can think that code owners are smart enough to differ wildcard and then like some straight path which includes in that wildcard. But in reality, just the last match wins. And for example, you have delegation to whole account to one team, and then you have some sub-path. No. If you have some sub-path first, and then you have delegation to whole team, this more concrete example will lose, and the next match will work. And it's not always clear. Okay, so all this stuff I was talking about, who should do that and when? And I honestly don't have an answer for that, because it could be different. I believe that all this stuff could be done from the beginning, like even if only a couple of engineers are working on the infrastructure as code, they already can prepare some like basement for the how infrastructure as code is developed in the company. I'm not saying that you should spend like all the time on this stuff instead of doing like really meaningful to the business changes, but if you have like some time, you can invest to that, and it will help you to grow your team, to onboard new members. And so instead of like this hidden knowledge, which is like some people are coming with different backgrounds, and you can start like this mess instead of organized stuff. And who should do that? I believe that some engineers could do that, just like if they want to do that. It's just, unfortunately, from my perspective, infrastructure engineering and like you can say DevOps engineers and SRE, they don't have much development experience, and they don't have much taste in like how they don't have much experience how in general like it looks like, and they are fine with anything. Like, so basically they are coming to the new company, and they have new practices in the company. Engineers are working together with these practices, but they are coming to the company with bad practices, for example, without infrastructure as code, with some like crappy examples I described earlier, and they are saying, fine, we work with that. But yeah, some engineers want to build this stuff just to be comfortable with. It could be work group of these engineers. Like in our case, for example, we have work group which is working on the Terraform, Kubernetes, and they are kind of supports this platforms. And it could also be, I saw this at my previous jobs, when manager or team lead has enough time and has enough kind of willing to build this stuff. Basically, I think he was only one engineer at that time, and he built this from the beginning, and it was much easier to come to the company and work with infrastructure as code in a normal way, not this chaotic stuff. So, as a summary, I believe that infrastructure as code at scale is not that simple. because growing it organically could be hard. There is no silver bullet, and I'm not providing it to you. So basically, it's all up to you, like how to build this stuff. I cannot sell it as a service. Like I cannot do consulting and say, like, let's do this. It's totally like up to you, up to your use cases, what should be in the quality gates, how you want to do code review, and whatever. And Monorepo keeps all these components of the platform in one place. Very easy to start, easy to change something, easy to add things, easy to remove things. You have to bother only with the code itself. You don't have to bother with the workflow of that. And the infrastructure as code requires support. It's not like 24/7 support, it's not on-call support, but like from once per week or a couple of times per month, there are some issues and there are always field to improvement that. Basically, that's all from my side. Thank you for listening to me. I have this social networks kinda. I'm writing to my Medium blog from time to time, and I have something related to this talk there as well. Thank you.
Thank you, Nicolai. We have time for like 2 quick questions. Okay, see 2 hands. Let's have.
Thank you for the talk. The question is Monorepo. Is it that you just kind of happened to use it and now you find kind of excuses, not in a bad sense, to use it, or you did really kind of test, like let's do it this way or that way, and it kind of proved to be the A/B testing proved to Monorepo is good approach?
Well, it was kind of like experimentally given like that. So at Bolt, when we started, we had the idea to keep different repos for different stuff. Like we keep some like GitHub repos management separately, then some other stuff separately. But eventually we came up with the idea at the beginning that it takes too much support and hassle to keep like everything in sync. So now we have platforms separated by the tools itself. So like we have platform Monorepo for Terraform, Monorepo for Ansible, Monorepo for Kubernetes. And we have some separate Terraform repos that not related to the Monorepo, general Monorepo, for different reasons. But it's way easier to support all of that.
Thank you.
Thank you for the presentation. A question regarding Terraform. Do you use Terraform workspaces, or do you prefer to have explicit code for every environment you have?
I know Anton Babenko, if you know him as well. He is a big hater of workspaces, and I agree with him. Workspaces are bad. We had them at some point in time in some legacy stuff, and we get rid of them successfully. Moreover, workspaces are different in the open source version of Terraform and the cloud version of Terraform. So I think there is no reason to use workspaces. We have fixed state, but we have some wrapper around Terraform. Actually, as I mentioned, this Slack article also says that they have wrapper around Terraform. So basically, this wrapper helps us to keep different like magic around Terraform, including state. And also we are using TerraGrant in some cases, which also helps us to keep this dynamic state.
Okay, let's all have a big applause for Nicolai. Thank you.
Thank you.